Welcome to another deep dive. Today we'll be looking into a really cool article from Jay's Lay.
Oh, yeah.
Yeah, it's called Precision Perfected, How Nuclear Clocks Are Changing Time.
Okay.
It was published yesterday, December 18th, 2024.
Very recent.
Yeah, and we're talking about like a possible revolution in timekeeping.
Hmm.
Clocks so accurate they wouldn't lose a second over billions of years.
Wow. That's pretty impressive.
It's wild.
Yeah.
So let's jump in and find out what's ticking.
All right. I'm intrigued. Where do we start?
Well, maybe let's start with the basics. What exactly are nuclear clocks?
Sure.
And how are they different from atomic clocks? I mean, I've heard of atomic clocks, but this is new territory for me.
Yeah, you're right. Most people have heard of atomic clocks, but nuclear clocks are a whole different ballgame.
Okay.
Both types of clocks rely on measuring transitions within atoms, but they focus on different parts.
Gotcha.
Atomic clocks measure transitions in the electron cloud surrounding the nucleus, while nuclear clocks zero in on transitions within the nucleus itself.
So we're going deeper into the heart of the atom then.
Exactly. And because the nucleus is much less affected by external factors, like magnetic fields or temperature changes, nuclear clocks can achieve unbelievable precision. Like, we're talking orders of magnitude more accurate than even the best atomic clocks we have today.
Now, that's mind-blowing.
Yeah.
But the article also mentioned some challenges in developing these clocks, right?
Yeah, there are definitely some hurdles.
Okay.
One of the main ones is working with Thorium-229.
Thorium-229?
Yeah. It's a specific isotope that's essential for these clocks.
Okay.
But it's incredibly rare and radioactive.
Ah, I see.
Which makes it expensive and difficult to handle.
The article actually said that Thorium-229 is more expensive than some custom proteins.
Yeah, that quote always gets me.
Wow.
It really puts things in perspective.
It does.
This stuff is really scarce and valuable.
Yeah.
It's been a major bottleneck in nuclear clock development.
So how have researchers overcome this obstacle? What's the secret ingredient?
Well, that's where this breakthrough comes in.
Okay.
Teams at JLA and UCLA figured out how to create these thin films of thorium tetrafluoride.
Thorium tetrafluoride.
Thorium tetrafluoride, or THFO for short.
TS, yeah. Okay, got it. Thin films, huh? How does that change things?
Well, for starters, these thin films are about 1,000 times less radioactive than previous methods.
Wow.
So they're much safer and easier to work with.
That makes sense.
Plus, they require way less material.
Okay.
Which obviously cuts down the cost significantly.
I see.
And here's the kicker. They're compatible with existing semiconductor and photonic technologies.
Really?
Yeah. So they could potentially be miniaturized in the future.
Wait, are we talking wristwatch-sized nuclear clocks someday?
Maybe. It sounds like sci-fi, but it could actually happen.
That's incredible. But hold on, how do they even make these thin films? It sounds pretty complicated.
Well, they use a process called physical vapor deposition.
Physical vapor what?
Deposition. It's also known as PVD. It's kind of like spray painting thorium onto a surface.
Spray painting with radioactive material. That's an interesting image.
It is kind of wild when you think about it like that. But to be more precise, they heat thorium fluoride until it vaporizes.
Okay.
And then they carefully allow it to condense on a specific substrate.
So what kind of surfaces are we talking about here?
They're using sapphire and magnesium fluoride.
Why those specifically?
They're transparent to ultraviolet light.
Okay.
And that's super important because they use UV light in the process to excite the thorium nuclei and measure their energy transitions.
That makes sense. So they've got this thin film of thorium, but it can't be as easy as that, right? I mean, a thin film isn't a perfect uniform crystal like they were using before.
You're right. That's one of the challenges with thin films.
Okay.
The atoms in a thin film have more varied environments than they would in a perfect crystal.
Okay.
Which leads to slightly different energy transitions.
Huh. So what does that mean exactly?
It's like trying to tune 1,000 slightly different radios to the same station at the same time.
Oh, I see. And there's no easy fix for that.
Well, there's a quote from Wolfgang Pauli that perfectly captures the challenge.
Oh, yeah?
He once said, "God invented the bulk and the surface is of the devil."
Okay, that's a pretty vivid picture. What does that mean in this context?
Well, in a bulk material, everything is uniform and predictable.
Uh-huh.
But on a surface, there are all sorts of unpredictable interactions happening.
I see. So how did the researchers at UCLA overcome this devilish surface problem?
They got creative and used what's called a broad spectrum laser.
A broad spectrum laser?
Yeah. They used it to excite the thorium nuclei in the film. This type of laser has a wider range of wavelengths,
Okay.
which allows them to excite the nuclei even with those slightly varied energy transitions.
Ah, so it's like they found a way to hit all those different radio stations at once. That's really clever.
Exactly. It was a brilliant solution, and it really highlights the collaborative nature of this research. Jay Jarre created the thin films, and then UCLA came in with the techniques to actually measure those nuclear transitions effectively.
This is also fascinating. We've talked about how nuclear clocks actually work, the challenges of the traditional materials, the breakthrough with the thin films, and even how those thin films are made.
It's pretty amazing stuff.
But what does this all mean for the future of timekeeping? What are the real-world implications?
That's where things get really interesting.
Okay. I'm all ears.
You see, this type of nuclear clock, a solid-state one, has a major advantage over trapped ion systems.
Oh, trapped ion systems.
Yeah, it's another approach to nuclear timekeeping.
Okay. I'm not familiar with that. What's the advantage of the solid-state system?
Well, solid-state systems can involve vastly more atoms.
Okay.
And that means they can be much more stable.
So we're talking about a more accurate and reliable clock.
You got it. And remember how these thin films are compatible with existing technologies? Well, that opens the door to miniaturization. Just imagine a wristwatch-sized nuclear clock.
Wow, that would be incredible. But let's be realistic. Even if we can miniaturize them, wouldn't they still be insanely expensive?
That's a valid concern, but remember, using thin films drastically reduces the amount of thorium-229 needed.
Right.
Which brings the cost down significantly.
So are we really talking about nuclear clocks becoming something everyone can have anytime soon?
Yeah.
Could I actually trade in my smartwatch for a nuclear-powered one in a few years?
Well, a nuclear-powered smartwatch might be a ways off.
Okay.
But the point is, this research has made nuclear clocks way more realistic for widespread use.
Gotcha.
And as production scales up and technology advances, the cost is likely to keep going down.
Okay.
So they'll become accessible for a much wider range of applications.
That makes sense.
Yeah.
So we've talked about the potential benefits, but are there any downsides to this level of accuracy in timekeeping?
Oh, that's a great question.
Yeah.
Yeah.
Could there be any unintended consequences?
You're right. That's definitely something scientists are thinking about very carefully. With any new technology, especially one this powerful, it's crucial to think about the potential implications, both good and bad.
Could you give some examples of what those implications might be?
Well, as we rely more on these ultra-precise clocks for things like global navigation and communication, any disruption or malfunction could have a huge ripple effect.
Oh, wow.
Imagine GPS satellites going haywire.
Oh, no.
Or financial transactions getting thrown into chaos because of a tiny timing error.
Yeah, that would be bad. Okay, so there are definitely some risks to think about, but let's shift gears for a moment.
Okay.
And talk about some of the exciting possibilities. The article mentioned that nuclear clocks could lead to new discoveries in physics.
Oh, absolutely. The potential there is huge.
Can you tell me more about that?
Well, one of the most interesting possibilities is in the search for dark matter and dark energy.
Dark matter and dark energy.
Yeah.
Wow. Those are some big mysteries.
They are. These two mysterious components make up most of the universe.
Really?
But we still don't know much about them.
Right. I've read that scientists have been trying to find dark matter for decades, but it's been really tough. How could nuclear clocks help with that?
One theory is that dark matter interacts very weakly with normal matter.
Okay.
And that causes tiny changes in fundamental constants.
Like what kinds of constants?
Like the speed of light, for example.
Wait a minute. Are you saying the speed of light might not be constant?
That's what scientists are trying to figure out, and that's where nuclear clocks come in. Because they're so precise, they could potentially detect even the tiniest variations in the speed of light.
I see.
And those variations might be caused by dark matter.
So we're talking about using these clocks as incredibly sensitive detectors to look for something we can't even see.
Exactly. It's like using a super-powered microscope to peer into the hidden structure of the universe.
That's pretty mind-blowing.
Yeah.
Are there any other areas of physics where nuclear clocks could have a big impact?
Oh, absolutely. Another really interesting area is the study of gravity. Einstein's theory of general relativity predicts that time is affected by gravity.
Okay.
It slows down in stronger gravitational fields.
So like time moves slower at the bottom of a mountain than at the top.
Exactly. And with nuclear clocks, we could actually measure those tiny time differences with incredible accuracy.
Wow.
Which would let us test Einstein's theory in totally new ways. And maybe even discover some new gravitational phenomena.
This is all so fascinating, but I have to admit, it's a lot to take in.
I know what you mean.
We've gone from talking about wristwatches to dark matter and the fundamental laws of physics. It's a bit overwhelming.
I get it, but that's what makes this research so exciting.
Yeah, you're right.
We're pushing the boundaries of what we know and opening up whole new avenues for exploration.
So where do we go from here? What are the next steps in this research?
Well, now that researchers have shown that using these thin films for nuclear clocks is possible, the next step is to optimize the technology.
What do you mean by optimize?
So improve the precision and stability of the clocks. Okay.
As well as exploring ways to make them smaller.
Miniaturize them.
Exactly.
And once they're optimized, what then?
Well, that's when things could get really interesting.
Yeah.
We might see a whole new generation of ultra-precise clocks being used in all sorts of applications.
Like what?
Everything from fundamental physics research to everyday technologies.
Can't wait to see what the future holds. It sounds like we're on the verge of a technological revolution.
It really does.
All thanks to the unbelievable accuracy of nuclear clocks.
It's an exciting time to be following this field, for sure.
Yeah.
Yeah, it really is remarkable to think about the potential impact these clocks could have.
Right.
Not just on science, but on our everyday lives.
Absolutely. Before we were talking about how this research could lead to wristwatch-sized nuclear clocks and even more accurate GPS, I have to ask, are we talking about centimeters here or millimeters?
Oh, we could potentially go even smaller than that.
Really?
Yeah, it all comes down to how well we can harness the potential of these clocks. Okay, so maybe forget the wristwatch for now. What about other practical uses? Where could we actually see this level of accuracy making a real difference in our lives?
One area that immediately comes to mind is telecommunications.
Okay.
With ultra-precise clocks, we could see a huge improvement in data synchronization.
What would that mean for the average person?
Think about it: faster and more reliable internet connections. Imagine lightning-fast downloads and seamless video streaming.
No more buffering. I'm listening.
Exactly. And it's not just about watching videos. Think about online gaming.
Oh, yeah, good point.
Precise timing is crucial for a smooth and responsive gaming experience.
For sure.
With nuclear clocks, we could say goodbye to lag and hello to a whole new level of gameplay.
That's a gamer's dream. So faster internet, better gaming, super accurate GPS. What else?
Well, consider the potential impact on financial transactions.
Okay, how so?
With more precise timekeeping, transactions could be processed almost instantly.
Wow.
Making global financial systems more efficient and secure.
That sounds like it could be a game changer for the financial industry.
Right, definitely. And then there are autonomous vehicles.
Self-driving cars.
Exactly. They rely heavily on accurate timing for navigation and collision avoidance. Nuclear clocks could make these systems even safer and more efficient. It could really revolutionize transportation.
It's mind-blowing to think about how something as basic as timekeeping could affect so many different areas of our lives. It's like a technological chain reaction.
It really is.
But before we get too carried away with all the possibilities, I want to come back to something you mentioned earlier. You said scientists are exploring the potential downsides of this technology. What kind of risks are we talking about?
One concern is that as we rely more and more on these ultra-precise clocks, we could become more vulnerable to disruptions.
Could you give me a specific example?
Sure. Imagine a scenario where someone interfered with the timing signals from GPS satellites.
Like a hacker?
Yeah, or some kind of malicious actor. The consequences could be really serious.
Yeah, I can see that.
It could affect everything from air travel to emergency services.
Okay, so security is a major concern. What else? Are there any other potential downsides?
Well, another thing to consider is the possibility that these clocks could actually worsen existing inequalities.
How so?
If access to this technology isn't evenly distributed,
I see.
It could create new divides between the haves and the have-nots.
That's a really important point. We need to ensure that everyone benefits from this technology, not just a select few.
Exactly. It's like any powerful tool. It can be used for good or for bad.
Right.
It's crucial to have these discussions now while the technology is still being developed, so we can work towards responsible and equitable implementation.
That's a perfect segue to something I wanted to discuss. Earlier, you mentioned that nuclear clocks could help us understand some of the universe's greatest mysteries.
Yeah.
I'm particularly fascinated by the idea that they could help us detect dark matter. Can you tell me more about that?
Sure. Dark matter is one of the biggest puzzles in physics today. We know it exists because of its gravitational effects on galaxies.
Right.
but we've never been able to directly observe it.
It's like this invisible force shaping the universe.
Exactly. And as we discussed earlier, one theory is that dark matter could interact with normal matter.
Okay.
And this interaction could cause tiny variations in things like the speed of light.
So you're saying these ultra-sensitive nuclear clocks could potentially pick up on those variations?
Precisely. They could essentially act as dark matter detectors.
Wow. That's a long shot, but if it worked, it would be revolutionary.
It really would. It just shows the incredible power of precision.
Sometimes the smallest measurements can lead to the biggest discoveries.
Exactly.
Speaking of big discoveries, the article also mentioned nuclear clocks and gravity.
Oh, right.
Can you expand on that a bit more?
Of course. So Einstein's theory of general relativity tells us that gravity affects time. It slows it down in stronger gravitational fields.
Right. The classic example being time moving slower at the bottom of a mountain than at the top.
Exactly. But the difference in time is incredibly tiny, making it very difficult to measure.
I see.
However, with nuclear clocks, we could potentially measure those subtle differences with amazing accuracy.
So we could actually test Einstein's theory in new ways.
Yes, precisely. It's like having a new, more powerful tool to investigate the fundamental laws of the universe.
It seems like the possibilities are truly endless when it comes to these nuclear clocks. It's both exciting and a little overwhelming.
I agree. It's a lot to wrap your head around, but it's important to remember that this is really just the beginning.
Okay.
We're only scratching the surface of what these clocks might be capable of.
Well, I, for one, can't wait to see what the future holds. But before we get lost in all the potential applications and implications, let's take a moment to consider what this all means for you, our listener. It's easy to get lost in the big picture stuff.
It is.
But you're right. The real impact of this is going to be felt in everyday life. One area you mentioned where we could see big changes is communication.
Yeah, communication could be totally transformed.
Okay, paint me a picture. What would that look like?
Imagine a world with, way faster, more reliable internet.
Okay, now you're talking. Who wouldn't want that?
Exactly. And that's what nuclear clocks could bring us. We could potentially see much faster data synchronization speeds. That means things like smoother video streaming, blazing fast downloads, even more responsive online gaming.
So no more buffering videos or lag in my games? Sign me up.
Exactly. And it's not just about entertainment either. These improvements could have a huge impact on things like telemedicine and remote work, making it easier for people to connect and work together from anywhere.
That's a good point. It's not just about convenience.
Right.
It's about accessibility to creating a more connected world.
Exactly. And like we talked about before, ultra-precise clocks could also revolutionize transportation.
Yeah, self-driving cars.
Exactly. Autonomous vehicles rely so much on accurate timing for things like navigation and collision avoidance.
Right.
Nuclear clocks could make their systems way safer and more efficient, paving the way for a future of self-driving cars and maybe even things like flying taxis.
Okay, now you're just making me want to jump into the future right now. But all this talk about super accurate clocks and how they could change the world, it's really got me thinking about time itself. It's something we take for granted.
I know, right?
But it's really profound when you actually stop and think about it.
It is. You're absolutely right. Time is fundamental to our existence.
Yeah.
And yet we're only just starting to understand what it really is.
Right.
These new timekeeping technologies aren't just about building a better clock. They're about pushing the boundaries of what we know and exploring the very fabric of reality.
That's a pretty deep thought.
It is. It really is. And I think we should remember that we're all part of this journey of discovery.
Yeah.
Every new scientific breakthrough, every technological innovation, it all brings us closer to understanding the universe and our place in it.
That's a great way to put it.
Yeah.
So as we wrap up this deep dive into the world of nuclear clocks, what's the one big takeaway you want to leave our listeners with?
I'd say this. We are right on the edge of a whole new era in timekeeping.
Okay.
One that has the potential to change not just technology, but our understanding of the universe itself. It's an exciting time to be alive, and I hope everyone keeps that spirit of curiosity and wonder as we explore all these new possibilities.
That's a perfect note to end on. It's been an incredible journey exploring the world of nuclear clocks and all the possibilities they hold, from things that could improve our daily lives to maybe unlocking the secrets of the cosmos.
The potential is huge.
These advancements have the power to reshape our world in ways we can only imagine. So as we come back up from this deep dive, we'll leave you with this.
If we can measure time with such amazing precision, what other things that seem unchangeable about our reality might we be able to understand and maybe even control someday? Until next time, keep exploring, keep asking questions, and keep diving deep.